Good day everyone. In this video, I will be discussing storage management. Here are the following terminologies that you need to know so that you can understand better this discussion. Disks are primary online storage medium for information in modern computer systems, both programs and data. Because main memory is typically too small to permanently store all data and programs, the computer system must provide secondary storage to back up main memory. The operating system provides a uniform, logical view of information storage to make the computer system more user friendly. The operating system defines a logical storage unit, the file, by abstracting from the physical properties of its storage devices. The operating system writes files to physical media and accesses them through storage devices. So, what is storage management? Storage management refers to all the processes and technologies that are used to manage the resources, software, and hardware that compromise data storage system. It entails achieving the best possible balance of cost, performance, and capacity while also ensuring the availability, resilience, and security of the data that drives an increasingly digital world. While the exact tools and techniques used to manage data storage will vary by organization, the following are some common storage management processes: provisioning, virtualization, containerization, data compression, data migration, data replication, disaster recovery, and automation. There are three types of memory in a computer system: high speed cache, main memory, and secondary memory. Now, high speed cache is a type of very fast memory. It is used to accelerate and synchronize with a high speed CPU. Cache memory is more expensive than main memory or disk memory, but less expensive than CPU registers. Cache memory is a type of memory that is extremely fast and serves as a buffer between RAM and the CPU. It stores frequently requested data and instructions so that the CPU can access them immediately when needed. The next is the main memory. Now, this is the part of the computer that stores the operating system, the software applications, and other data for the central processing unit or the CPU to have quick and direct access to when performing tasks. The term random access refers to the fact that the CPU can go directly to any section of main memory and does not have to go through the process in a sequential order. The main memory in a computer is called random access memory, or also known as RAM. There are different kinds of RAM. We have the DRAM, or the dynamic random access memory, and the SRAM, or the static random access memory. Lastly, we have the secondary memory. Now, the secondary memory is a physical device for the permanent storage of programs and data. Although secondary memory is much slower than primary memory, it typically has a far greater storage capacity. Storage devices such as hard drives and solid state drives are examples of secondary memory. It could also refer to removable storage media like USB flash drives, CDs, and DVDs. We now go to disk scheduling. A process requires two kinds of time, the CPU time and the IO time, or the input output time. It takes the operating system to access the disk for the IO. However, the operating system must be far enough to satisfy each request while also maintaining the efficiency and speed of process execution. This scheduling refers to the technique used by the operating system to determine which request should be fulfilled next. Now, here are the following reasons why this scheduling is important. First is multiple I/O requests may arrive from different processes, and the disk controller can only serve one input-output request at a time. As a result, other input-output requests must wait in the waiting queue and be scheduled. Another is two or more requests may be far apart, resulting in more disk arm movement. Lastly is because hard drives are one of the slowest parts of a computer system, they must be accessed as quickly as possible. Let us now go to disk scheduling algorithm. Now, the disk scheduling algorithm's main purpose is to select a disk request from a queue of input-output requests and determine when this request will be processed. Now, this scheduling algorithm has three goals: fairness, high throughput, and minimal traveling head time. Here are the following list of various disk scheduling algorithms. Each algorithm has its own set of advantages and disadvantages. Now, each algorithm limitation leads to the evolution of a new algorithm. First, we have the FCFS scheduling algorithm, or the first come first serve scheduling algorithm. Now, it is the most basic disk scheduling algorithm. It handles input output requests in the order that they arrive. In this algorithm, there is no starvation. Every request is met. Next, we have the SSTF, or the shortest seek time first algorithm. Now, the algorithm, or this algorithm selects the disk input output request that requires the least amount of disk arm movement from its current position, regardless of direction. It or is known as the shortest seek time first, or the SSTF. When compared to FCFS, it reduces total seek time. It enables the head to move to the next available track in the service queue. The third is the scan scheduling. Elevator algorithm is another name for it. In this algorithm, the disk arm moves in a specific direction until it reaches the end, satisfying all requests in its path, and then it turns back and moves in the opposite direction, satisfying requests in its path. It operates similarly to an elevator in that it moves in one direction until it reaches the last floor in the direction and then reverses direction. Fourth, we have the C-scan scheduling. The arm of the disk moves in a specific direction, servicing requests until it reaches the last cylinder, Then it jumps to the last cylinder of the opposite direction without servicing any request. Then it turns back and starts moving in that direction, servicing the remaining request. Second to the last, we have the look scheduling. Now, it is similar to the scan scheduling algorithm in some ways, except that in this scheduling algorithm, the arm of the disk stops moving inwards or outwards when there are no more requests in that direction. This algorithm attempts to overcome the overhead of the scan algorithm, which forces the disk arm to move in one direction until the end, regardless of whether or not a request exists in that direction. Lastly, we have the C-look scheduling. To some extent, the C-look algorithm is similar to the C-scan algorithm. In this algorithm, the disk arm moves outwards, servicing requests until it reaches the highest request cylinder. Then it jumps to the lowest request cylinder without servicing any request, and then it moves outwards again, servicing the remaining request. It differs from the C-scan algorithm in that C-scan forces the disk arm to move at the last cylinder regardless of whether or not any requests are to be serviced on that cylinder. And that's it for this topic. Thanks for watching.